Hi, I'm a senior software engineer at SUSE. This has nothing to do with SUSE. This is just me unleashing some rage upon you. So, first of all, what do I mean when I say they're considered harmful? The base problem that I'm going to be talking about right now in the next 4 and a bit minutes is that every single container ecosystem out there uses tar archives for layers. This includes LXD, Rocket, Docker, and basically every single one of them, one exception being Singularity. They use loopback files. That's a different problem. Let's not get into it. The point is that container images are basically broken by every single container runtime, and we really need to solve it. The full rant for this version is about 3 hours long. I will gladly go over it with a beer with you, but for now, I'll try to condense it as short as I can. There are a couple of other issues involving container images, mainly about how opaque they are and how you can't tell what's inside them. That's a whole nother issue. Again, see me afterwards if you'd like me to rant about that. So, a very common point that people have been bringing up in this conference is that we need to make our images smaller and more lean and so on and so on. It's my view that actually making smaller layers and fewer layers, while solves the problem right now, is actually avoiding a much more fundamental problem, which is that all container image formats are doing the wrong thing. And in my defense, I made this meme late last night. So why does tar suck? The first thing is that it's not standardized at all. There are three. First of all, the undisk format has no standard. The standard is whatever GNU tar accepts. It has 3 different effectively incompatible extension formats called PAX, the GNU one, and Chili. They're all incompatible. They have overlapping feature sets. So if you want to use like different features, like if you want to use CTime and you want to have extended attributes in the same file, you need to use more than one extension format in order to do that. And they have different support levels, so mixing these extension formats doesn't actually always work. There are also some other issues that are more prevalent towards containers, which is that the order of tar entries is actually implementation defined and might not be reproducible. For instance, GNU tar generates different archives to Go's tar. So in other words, if you have the exact same file system, even if you tell Go to generate the exact same order of the files, it will generate a different file, which means a different hash, which means if you like content-addressable images, you now have a copy of the same layer, even though it has the exact same contents and will extract the exact same thing. And in fact, Go 1.10 has a fix for an archive tar bug I found, and it will now create slightly different archives to Go 1.9, which means when Docker upgrades from Go 1.9 to Go 1.10, all of your images will be built with slightly different archives. Now, you won't notice this necessarily, but it will mean you'll duplicate all these layers for no good reason. And you can actually even have duplicate entries for the same file in a single archive. Don't ask me why that's possible. It's another historical thing. So, why does tar extraction suck? Well, each entry is stored one after another. It's a sequential format, and that means if you knew that there was a file you wanted to extract, you'd have to scan the entire file to extract it. And you cannot extract it in parallel because there is no index of what files are in it, and there's no offset to where they are. So in other words, if you have to extract a tar archive, you have to read through the entire thing, extract everything, and it's very slow, no parallelism at all. I don't know about you, but when I do Docker pulls or any other image extraction, it's always slow, and this is one of the reasons why. Why does tar layering suck? Any method data change, including, for instance, changing the access time of a file, causes the whole file to be copied to a new layer's archive. If you have a file in your container and you touch it, it will now have a full copy of that in the upper layer. This happens for everything, not just content changes, but just metadata changes, as I said. This means that layer level deduplication is basically useless because any small change breaks it for the entire layer. Not to mention that layer level deduplication actually loses one of the main things that is the case with distributions, which is that we all package the same software effectively. And so you have all this duplication with all your different images, which is completely missed by the fact that we use these tar archives. And also, if you change a file in multiple layers, it will be extracted multiple times because, as before, there is no index, so you cannot actually figure out which layer contains the newest version of a file. So, can we do any better? Of course we can. As it turns out, backup tools actually have solved this problem for at least a decade with tarsnap and with newer tools like Restic and Borg backup and things like that. It's actually quite trivial on paper to do. Obviously, the downside is you have to implement it. But if you have a more clever indexed format, you can allow parallel extraction. Using content-defined chunking with rolling hashes, you can get intra-layer deduplication. So if you have a file and you change 1 byte in it, you don't duplicate the entire file in each layer, you just duplicate one of the chunks. And content addressable, if you have a content addressable store, like the Open Container Initiative's image format does, you can actually get intra-image deduplication, where if you have Ubuntu and you have Red Hat and you have SUSE images, they all package the same version of Bash, basically. Why do you need to have 3 copies of Bash on your system for every single image you have? And a new format means we can actually make it sanely extensible to add cool features like the ones that LXC has, such as templates and things like AppC's, dependencies and things like that. So I have 17 seconds left, so I thank you very much, and thanks for bearing with that.